தேனி மேலப்பேட்டை இந்து நாடார்கள் உறவின் முறை நாடார் சரஸ்வதி பொறியியல் மற்றும் தொழில்நுட்ப கல்லூரி, வடபுதுப்பட்டி, தேனி. தமிழகத்தின் மிகச்சிறந்த பொறியியல் கல்லூரிக்கான டாக்டர் கலாம் விருதினை பெற்ற கல்லூரி. பயிற்றுவிக்கப்படும் பாடப்பிரிவுகள்: BE சிவில் இன்ஜினியரிங், BE கம்ப்யூட்டர் சயின்ஸ் அண்ட் இன்ஜினியரிங், BE எலக்ட்ரானிக்ஸ் அண்ட் கம்யூனிகேஷன் இன்ஜினியரிங், BE எலக்ட்ரிக்கல் அண்ட் எலக்ட்ரானிக்ஸ் இன்ஜினியரிங், BE மெக்கானிக்கல் இன்ஜினியரிங், ME மேனுஃபேக்சரிங் இன்ஜினியரிங், ME ஸ்ட்ரக்சரல் இன்ஜினியரிங். தொடர்ச்சியாக அண்ணா பல்கலைக்கழக தரவரிசை பட்டியலில் மாவட்ட அளவில் முதலிடம் மற்றும் மாநில அளவில் சிறப்பிடம் பெற்ற கல்லூரி. இயந்திரவியல் துறையில் ஆராய்ச்சி மையத்திற்கான அங்கீகாரம் பெற்ற கல்லூரி. பன்னாட்டு நிறுவனங்களில் 76% மாணவர்கள் வேலை வாய்ப்பினை பெற்றுள்ளார்கள். மதிப்பெண் அடிப்படையில் கல்வி கட்டண சலுகை. விளையாட்டுத் துறையில் சிறந்து விளங்கும் மாணவர்களுக்கு கல்வி கட்டணத்தில் சலுகை. தேனியை சுற்றியுள்ள அனைத்து ஊர்களுக்கும் பாதுகாப்பான பேருந்து வசதி. மாணவ மாணவிகளுக்கு தனித்தனியான சிறந்த விடுதி வசதி உள்ளது. சிறந்த நூலக வசதி மற்றும் குளிரூட்டப்பட்ட ஆய்வக வசதி. முதல் பட்டதாரி மாணவர்களுக்கு கல்வி கட்டணத்தில் சலுகை. டிசைன் யோர் டெஸ்டினி போட்டியில் மாநில அளவில் முதல் பரிசு வென்ற கல்லூரி மாணவர்கள். பொறியியல் படிப்புகளுக்கான ஆன்லைன் விண்ணப்பங்கள் கட்டணமின்றி பதிவு செய்ய எங்கள் சேர்க்கை மையங்களை தொடர்பு கொள்ளவும். கவுன்சிலிங் கோட் 5865. நாடார் சரஸ்வதி பொறியியல் மற்றும் தொழில்நுட்ப கல்லூரி, வடபுதுப்பட்டி, தேனி. மேலும் அட்மிஷன் தொடர்புக்கு 9095100235 and 9095100278, 9095100228, phone 04546 263900 and 263901. மேலப்பேட்டை இந்து நாடார்கள் உறவின் முறை நாடார் சரஸ்வதி பொறியியல் மற்றும் தொழில்நுட்ப கல்லூரி, வடபுதுப்பட்டி, தேனி. தமிழகத்தின் மிகச்சிறந்த பொறியியல் கல்லூரிக்கான டாக்டர் கலாம் விருதினை பெற்ற கல்லூரி. பயிற்றுவிக்கப்படும் பாடப்பிரிவுகள்: BE சிவில் இன்ஜினியரிங், BE கம்ப்யூட்டர் சயின்ஸ் அண்ட் இன்ஜினியரிங், BE எலக்ட்ரானிக்ஸ் அண்ட் கம்யூனிகேஷன் இன்ஜினியரிங், BE எலக்ட்ரிக்கல் அண்ட் எலக்ட்ரானிக்ஸ் இன்ஜினியரிங், BE மெக்கானிக்கல் இன்ஜினியரிங், ME மேனுஃபேக்சரிங் இன்ஜினியரிங், ME ஸ்ட்ரக்சரல் இன்ஜினியரிங். தொடர்ச்சியாக அண்ணா பல்கலைக்கழக தரவரிசை பட்டியலில் மாவட்ட அளவில் முதலிடம் மற்றும் மாநில அளவில் சிறப்பிடம் பெற்ற கல்லூரி. இயந்திரவியல் துறையில் ஆராய்ச்சி மையத்திற்கான அங்கீகாரம் பெற்ற கல்லூரி. பன்னாட்டு நிறுவனங்களில் 76% மாணவர்கள் வேலை வாய்ப்பினை பெற்றுள்ளார்கள். மதிப்பெண் அடிப்படையில் கல்வி கட்டண சலுகை. விளையாட்டுத் துறையில் சிறந்து விளங்கும் மாணவர்களுக்கு கல்வி கட்டணத்தில் சலுகை. தேனியை சுற்றியுள்ள அனைத்து ஊர்களுக்கும் பாதுகாப்பான பேருந்து வசதி. மாணவ மாணவிகளுக்கு தனித்தனியான சிறந்த விடுதி வசதி உள்ளது. சிறந்த நூலக வசதி மற்றும் குளிரூட்டப்பட்ட ஆய்வக வசதி. முதல் பட்டதாரி மாணவர்களுக்கு கல்வி கட்டணத்தில் சலுகை. டிசைன் யோர் டெஸ்டினி போட்டியில் மாநில அளவில் முதல் பரிசு வென்ற கல்லூரி மாணவர்கள். பொறியியல் படிப்புகளுக்கான ஆன்லைன் விண்ணப்பங்கள் கட்டணமின்றி பதிவு செய்ய எங்கள் சேர்க்கை மையங்களை தொடர்பு கொள்ளவும். கவுன்சிலிங் கோட் 5865. நாடார் சரஸ்வதி பொறியியல் மற்றும் தொழில்நுட்ப கல்லூரி, வடபுதுப்பட்டி, தேனி. மேலும் அட்மிஷன் தொடர்புக்கு 9095100235 and 9095100278, 9095100228. Phone 04546 263900 and 263901.
Kumar sir.
Okay, sir.
I think you can start the session.
1 second, sir. Ma'am, Sujita ma'am. Ma'am, visual ma'am. Sujita ma'am.
Sujita madam, your visual please.
Ma'am. Ma'am, Sujita ma'am.
1 second, sir. Madam, time start பண்ணுங்க.
Yes, ma'am.
Good morning, all. I hope all of you stay safe. Behalf of Nadar Saraswati College of Engineering and Technology, Department of Electrical and Electronics Engineering conduct a wonderful webinar on Introduction to Substation and Distribution System. I welcome all the participants, students, faculties from various colleges. I request all the participants to mute their microphones and actively participate in the session, and end of the session post your queries in a chat box. Now I welcome Head of EEE Department, Mr. M. Vairavelavan sir, to propose a welcome address. Welcome, sir.
Thank you, madam. A very pleasant good morning to one and all. I welcome all of you to this webinar on Introduction to Substation and Distribution System. It is my pleasure, and I thank our management for giving us this opportunity. I thank our secretary, Mr. K.S. Kasim sir, and joint secretary, Mr. A. Rajkumar sir, for supporting us. And I welcome our principal, Dr. C. Mahalai Sundaram, for being encouraging and giving us this opportunity. I also welcome vice principals, placement officer, head of various departments, faculties, students, participants from various institutes, and I welcome you all once again. It is my privilege and pleasure to introduce the guest of today, Mr. C. Vairavelavan, Engineering Manager, L&T Construction, Dubai. He is having a comprehensive experience in the field of electrical engineering. Presently, he has around 14 years of experience in EHV substation detailed design and analysis, majorly in Africa region. He completed his BE in Electrical and Electronics Engineering from Pandian Saraswati Yadav Engineering College. Immediately after completing his undergraduate, he joined as a substation proposal and executing personnel at National Contracting Company, Chennai, handling projects for Africa and Bangladesh. Subsequently, with his vast experience, he joined Electrical Major ABB, and where he worked for around 3 years in high voltage substation proposal and execution for Australia and USA projects. Since 2015 onwards, he has been with L&T Construction, Dubai, as Electrical Engineering Design Manager. He is having vast experience in substation design associated with project and proposal development. He is a professional engineer having direct experience in the transmission utility industry. Major experiences are in the areas of substation design from 11 kV to 500 kV levels, as well as he has a solid and firm understanding of all disciplines of substations like protection and control, SCADA, telecommunication, and knowledge, and in associated general civil and structural engineering. I hope the session will be a grand success with such a guest with vast experience. Thank you, Mr. Vairavelavan, for accepting our invite. And over to Mr. Vairavelavan. Thank you.
Thank you, Mr. Vairavelavan, and it's my pleasure to give this webinar. So first of all, good morning, all the participants, faculty, and the industrialist and student. Welcome you all for this webinar, Introduction to Substation and Distribution System. So first of all, thanks to Nadar Saraswati Engineering College who given this opportunity for the webinar. And thanks to Mr. Arivalagan, the HOD of Electrical and Electronics Department. So I hope everyone is safe and well connected. So I am looking here, the participants are 100 in this Zoom meeting, and there is a live program is going in YouTube as well. So, okay, I think we can start the program. So I request Mr. Arivalagan to, shall I continue for the presentation?
Yes, sir, please.
Okay. So let me just close my video because for the convenience of the communication and the clear in the presentation. Okay. All the participants, thank you. Then I have similarly, I request all the participants, you mute your mic, and I don't think no need to switch on your videos. Okay. All right. Thank you. Let's share my screen for the presentation. Mr. Arivalagan, I'm checking the YouTube live also, but it's not appearing any of my screen, just to make sure so that I can start. presentation?
Sir, it is on live, sir. It will take around 2 to 3 seconds to come to YouTube, sir. You please
Okay.
continue in Zoom, sir.
Okay, fine. So you can you able to see my presentation? Is it clear
sir.
to you?
Yes, sir.
Yes, sir, it is visible.
Okay, fine, right. Go ahead. Thank you once again. So let's start the presentation. So we are in Introduction to Substation and Distribution System. So my name is Vairavelavan. I am the electrical engineer working in currently associated with Larsen & Toubro, Dubai. So I have experience in extra high voltage substation and distribution system, both in proposal and contract executions and the project executions as well. Okay. So it's okay. So industry is concerned, the safety is very important. So let's start with the safety for some safety tip today. So don't call or answer the phone while charging. So just is the safety of the day. So let's start with some acronym which we are going to use it in our presentation.
Sir, your microphone is muted, sir.
1 minute.
Yeah. It's
Just
good,
a
sir.
minute.
No problem, sir. It's audible, sir.
Okay, fine. Is it clear now?
Yes, sir.
Okay, so let's start with the safety of the presentation today. So it's a safety tips for the day is, so we need to, while your mobile is in charging mode, don't do call any answer the call. So that's a safety because we are in the industrial presentation. So always we need to start with the safety tips. Okay. So these are the acronyms which we are going to use it in our presentation. So you need to understand the HV whenever I am mentioning the HV, MV and LV, SS and TND, the TND means the transmission and distribution. When I say the load always defined as a residential customer or industrial customer. Okay. Okay, before moving to the detailed presentation, what I like to show you. So maybe a lot of people come across the power system. The power system, it consists of generation, the transmission and distribution, and including the customer, either industrial customer or residential customer. Okay, now let's understand the basis of the power system. So before move into the substation, because exactly where the substation is located, so that we can able to understand where substation is located, what for the substation is. The reason of the substation can be well understood by the people. So now everybody, I think, including students or who were from other department as well. So they know about the generation we come across, which is either thermal or nuclear or hydropower plant or solar power plant and wind power plant. So all this energy. Okay, so I'm sorry. Once again, someone is raising the hand. Sorry, sir. Mr. Murugan.
Sir, queries will be answered at the last of the session, sir. Please lower your hands. Thank you.
Okay, sorry. Okay, so just understand the power system fundamental, then only we can move to the substation. So just I request all participants, let's move the presentation until end of the session. Then we will give the opportunity for the participants to ask the questions. Okay, thank you. So once it's a power generation, there is a power generation. So we like to deliver this power in a reliable and efficient way to the end user. End user here is the customer, is a residential or industrial customer. So what we are going to do, the power is going to be transmit in a tower or extra high voltage or medium voltage, and it is going to connected to the industrial or residential customer through the distribution network. So the in between during the transmission, we are going to implement the subsidiary of the system, which is called the substation. Okay, so to having this understanding, let's start this presentation. Then I would like to show you some of the volume of the transmission line. So this is to understand the participant really in India, what is the quantum of the transmission lines, which will help you why we are studying this substation. Okay. I hope everybody can see this. Just I want to make sure, are you able to see my screen? Is it okay? The major high voltage network with the map.
Yes, sir, it is visible.
Okay, right. Thank you. So this, if you look at this Indian map, what you have shown is above 400 kV, all the transmission line network. You can see even the full of map is covered with transmission line, I would say. And even the left hand side of your screen, it's showing the 220 kV above transmission line in the Tamil Nadu district. Okay, so now the reason I am showing this, because you need to understand, the people have to understand what is the volume of our network, why we are going from low voltage to the high voltage and extra high voltage, and now towards the 1000 kV for the system. Maybe in India nowadays started with the 750 kV system as well. Okay, so the electrical engineer have to understand this. So that is the reasons we are studying the extra high voltage network and the system. Okay, then just a recap our Indian power generation capability. So we have almost 3.7 lakhs of megawatt generation. Then southern region, it is 1.1 lakh of megawatt generation is there. So have a look on it, and which will help you, what is our volume of generation. Because to this much, there is a power generation. So how we are going to deliver this power to the end customer in a stable way. So what we are talking about is today, it is only the substation. It is a subsidiary of the power system, maybe one core edge of the field. Because there is, when you say power system, it starts from the generation, transmission, distribution, and subsidiary system like a substation and your compensation devices, your some of the reactive power compensations. Then nowadays there is a HVDC transmission. So we are not going to cover all those things, but we are going to talk about only the air insulator substation today, because it's an introduction. So let's start with the beginning. Then maybe upcoming sessions, there is an opportunity, then we can explore more on it. Okay. Okay, now we are going into the real content for this substation and distribution system introduction. So what I'm going to cover here, what is substation, how it will be look like, what is the model of the station, then what are the equipments are in the substation, then what is the distribution, then model of the distribution station, then what are the distribution equipments, then finally I'm going to touch upon the list of manufacturer, then the contractor and construction firms. Maybe it will help for the student to understand who are all the manufacturers as well as the contractors are available. You can keep an eye on it, so that for your it may help for your career. Okay, let's move to the distribution and substation and distribution model I have shown in my presentation. Let's wait for some minutes so that it will update your end the presentation. Okay, I hope it's received. So now when you look at this model, I took one of the typical model, how the flow of power from one end to the destination, or from the generation to the destination. So that is what the top to bottom approach I have shown on your map as well. If you look at it, this generation, let's take any of the generation. You can take a thermal or nuclear, whatever it is. Then the amount of quantum of generation power is going to be transmitted through the transmission lines. Before transmission, there is a subsidiary system. It means the system is going to help for the transmission to to taking care of the transmission line losses. Then the efficient and reliable way of transmission. So we are implementing a system which is called the substation. It is normally a step up substation we call. The reason is, what will happen, the generation, if you let's take 33 kV level or 11 kV level, the main substation which is closer to your power station, normally a step up. It means it will rise the voltage from the generation to the transmission capable level. Okay. Then after transmission line, you can see, let me put my cursor so that it will be clear to you. Okay, these are the transmission lines. Then it is traveling to receiving and substation. This is called just a reverse of this particular the generation station, which means it will step down the voltage. Then let's take the transmission is happened in 765 kV, and after this reaching this receiving end station, what this receiving end station will do, it will step down further to either 400 kV or 220 kV. Then it will transfer to the distribution substation. It may be a 220 by 33 kV level or 11 kV level. Then further from this point, after the distribution station, so it will traveling to your bulk consumer like industrial customer, or it is going to the residential customer through the 11 kV distribution network. Then again, there will be a pole mounted the transformers. Normally you will saw in your roadside on the left hand side of the road normally. So this transformers helps to reduce the voltage for the residential customer, which is a 415 volt, the 3-phase. So now if you look at this overall map, you can see there is a substation closer to the power generation, number 1. Number 2, the receiving station. Number 3, the distribution substation, which converting into the medium voltage. Then after that, there is a substation we call pole mounted substation on the distribution pole. Okay. So this is the industrial customer. This is also the distribution pole mounted transformer. This is also a distribution pole mounted transformer. Okay, so now we are identifying what is substation, where it is located. That is what I was trying to explain for the participant. Let's move to the definition of the substation. As I said, it is a subsidiary. Okay, let's wait for a few minutes. Okay, the substation is a subsidiary of the electrical generation and transmission and distribution. It is increasing or decreasing the voltage for the power transfer from one place to the another place to minimize the loss. Then distribution system, which is called the final destination. So before reaching to the end user, it is a kind of a network which helps to distribute the power for the various utilities. Various residential and industrial customer. Okay, that is the core definition. So which you like to read it, somebody, you can read it. Let's hold for some time. Okay, let's move to the next slide. I am in slide 10. Okay, basically what I have, okay, the previous one slide which I indicated in the form of a pictorial representation. Now we are going into the line diagram. So normally when you are working in a core field, the representation of the substation and the power network will be look like this. Okay, so what you need to understand, so this is the one substation, one power plant. So you can see that these are all generators, then which is connected to your step-up transformers and feeders. Then this black line, what you are seeing is a transmission line, either is 765 kV or 420 kV and 220 kV voltage levels normally. Then then this is also another power plant, because I wanted to show you in a little elaborative way. So the two substation is connected to the one substation. Then again from this substation, which is traveling to neighbor locations probably. Then from the receiving station, subsequently there is one more distribution station. Then you can look at it, this the pink color, which is called the distribution substation. Distribution substations. Then ultimately it is going to your industrial customer, then the residential customer. Just to hold on. Okay, now what we are going to talk about, we are going to take one of the station. Probably we will take enlarged view of this particular stations, we are going to understand what are the components involved in this substation. Okay. Okay, let's wait, hold for a few minutes to update the presentation at your end. Okay, when you look at this enlarged view of station, so there is a line which is connected to the station. This all component we will say is a line feeder. So now what you're looking is a 3 line feeders in this station. Then the transformer feeder, this is called the transformer feeder. Here the majorly all switchgear and the transformer is involved. Then again, this is the outgoing line feeder. So basically this is the incoming line feeder. This is the outgoing line feeder. Then this is a transformer feeder. Now let's again enlarge this line feeder, the incoming line feeder. We like to look at it. What are the components involved? Okay, when you look at look at this line feeder, what you are seeing, these are all switchgear. We call it as a switchgear. So when the transmission line is connected to your substation, the foremost thing what you need to take care, you need to take care the surges. Basically, there is a 2 phenomena in substation design. Number 1, there is a switching surge. When you connect the load or when you switch on the breakers, let's give a layman language. In our home, if you try to switch on your normal light switches, you can see there is a spark in it. So which is called, it is generated by the some surges inside. So like that, in extra high voltage and high voltage network, there will be a surges when you close the switches. So when doing this operation, there will be a surge. Number 1, it will generate. Our second phenomena is your natural phenomena, which is called, if there is a lightning strike on the transmission line, the outside of the station, the traveling waves which is reaching your substation. So what is the prime thing? We need to stop these surges getting into the station. It is a nuisance. For those surges, you need to bypass into the earth. So what we are using, the first component is a lightning arrestor, which helps to bypass your all the surges into the ground. Then number 2 is a voltage transformer. What is voltage transformer? It is called instrument transformer. It is a part of instrument transformer. The reason is, when you receive the transmission line, either control system or the human, or it means the operator, must know what is the voltage we are receiving. So the control system will operate or protect the system based on this, the voltage measurement. Number 2, the operator will understand what voltage we are receiving. Not only the voltage, which will help to monitor the energy as well as for the power in the network. It means the delivery of power and the energy for export or import from the network. Then third item is a disconnector. It is basically a no load operating switching device. And you can see there is a earth switch as well. This is called earth switch. This is earth switch. Let me represent E so that people will understand. So this is the earth switch. Let's talk about earth switch. What is for the reason? Let me tell you. Before that, you need to understand why we are putting earth switch on the line. Basically, the earth switch, which helps to, is a protective device. When your transmission line is connected to the other end of the station, for let's say generating station, power is traveling from the generating station to the receiving station. Okay, I'm switching off the particular feeder. It means the generating station side, I'm closing the transmission line for the maintenance purpose, let's say. Then we need to also open this isolator. We need to close this earth switch, because this is for the safety reason. If someone is switching on wrongly, or for electrocution should not happen. So for the safety reason, this earth switch is placed. So people normally, when it is in switch off condition, this feeder is in switched off condition, the earth switch will be in closed position. Okay, let's just keep the next device is the current transformer. It is a part of instrument transformer. So there is a two instrument transformer. One is the current transformer, then another is voltage transformer. The both are called instrument transformer, which we will study in the instrumentation subject. So both this current transformer also, it helps to measure the current flowing in the incoming feeder. The voltage transformer is helps to monitor the voltage. The current transformer is helps to monitor the current. What it will do when here is a high voltage, the high voltage will be reduced to 110 volt for the monitoring purpose. Similarly, there is a flow of current 1000 amps. Let's take 1000 amps in the high voltage network. It will give you the output of the proportionally less than 1 amps or 5 amps. So that is the design of current transformer. Okay, then next device is switchgear is circuit breaker. This is the crucial one which helps you for normal and abnormal state of the system. Basically, the circuit breaker is have the capable to make and break the load, which means close and open the particular feeder when it is in operation. So this circuit breaker normally is a maybe we have studied air brake circuit breaker, then hydraulic circuit breakers, then we will say the SF6 circuit breaker. Predominantly the SF6 circuit breakers are used in high voltage network. Then the next switchgear is the disconnector, which helps to connect it to your bus bar. Okay, what is bus bar? We need to understand the bus bar first. So when you say the bus bar, there is a multiple feeders are coming to the substation. Then there are one, two, three. There are multiple transformers are connected to the system. So these two the line and transformer feeders is connected with one point that is called the bus bar, which is nothing but your aluminum tube or is a conductor. So it is okay. Let's show some photographs so that you will understand what is bus bar. Okay, let's that will be covered in the upcoming slides. Let's just understand the component, then we'll move on. So now the disconnector is what it is going to help when this breaker is in off condition. So this disconnectors, this and the line disconnector, both will be open. So that the circuit breaker, you can take it for the maintenance or the control system failures, or you can replace the circuit breakers that time, which is helping for a lot. So all the component, it's called all the components, we call it as a switchgear, which is part of the line feeders. Let's take the transformer feeder, then let's understand all. Okay, so what I have shown from the bus bar, I have took this enlarged view of the transformer feeder. I have shown it here so that the component can be understood by the people. So now you see the same disconnector. When you connect any of the component, the first thing from the bus bar must be a disconnector. It is a no load device helping for or assisting the circuit breaker when it is in the operation, you can say. So the circuit breaker is a prime device which helps to protect your either transformer or is a line feeder when it is in the operation. So basically a control system will give the command to the circuit breaker. If any abnormal, this breaker will be get open. Okay, after the breaker open, if people wanted to work with the power transformer, they must open the disconnector followed by the circuit breaker open, then only they can go for operation of the transformer or any device failures. Okay, what are the components in the power transformer? It is similar like a line feeder, which is number one disconnector, circuit breaker, then the current transformer, which helps to monitor the current flowing into the power transformer. Then finally the lightning arrestor. Lightning arrestor, because power transformer is a prime component equipment used in the major cost of the substations will be because of the power transformers. So we need to give the real protection, especially for the power transformer. So what we need to put mandatorily, we need to place the lightning arrestor on the primary as well as secondary of the equipment. That is mandatory. So just a summary. So what we covered, we understand the line feeder. What is a line feeder? Which is coming from the transmission line called line feeder. Then the transformers helps to step up and step down. The equipments and transformer together, which is called the transformer feeder. So all the components is used in the line feeder and transformer feeders are gone through. Okay, let's move to the next slide. Okay, so what I have presented here, it is a real engineering representation of the substation. When you go for a design engineer of substation, normally the substation start with the line diagram. Substation start with the line diagram. So the line diagram will helps to understand what are the line feeders, where it is coming from. Let's take from city 1 and city 2, which is connected to city 3. So city 3, we are constructing a new substation. So we need to understand how many line feeders are there, from which direction it is. Then we will form the bus bar. Then from the bus bar, the transformers are connected. Okay, here this particular single line diagram, because the previous slide I have indicated only one bus bar. So people need to understand why I have mentioned two bus bar. Okay, there are a bus bar classification is there in the system. So what is bus bar? Is either is a single bus bar or double bus bar, which are helping to improve the reliability of the system. Okay, so okay, that will be covered in the advanced course, but in the introduction, just understand the bus bar helps to connect the line feeder and the transformer feeder. Then if you just enlarge this single line diagram, you will get the representation of the layout. So the layout, if you look at it, you can see all the red lines are the power transformer. The power transformer is in a rectangular shape. You can able to see it. So, and I have also represented is the transformer bay, and this is the line feeder bay, and you can see this is the control room. So now the physical layout, maybe I would say for the length and breadth of the stations will be 150 meter by 100 meter. Okay, so that will be the size of the station, and basically it is all air insulated switchgear substations. Then the control room helps to monitor the whole station. The operators are located here. Okay, then let's move to the next slide. Okay, now what we are seeing is a three-dimensional photograph. Okay, the photograph taken from the Tron. Now you can able to understand by given a previous explanation. So from the transmission line, these are all the transmission lines. Okay, from the transmission line, it will come from various towns and cities. Let's take. Then from the transmission line, it is connected to your line feeder. So these components are the line feeders. Okay, then if you look at this side, there is a transmission line, and it is connected to the transformer. Sorry, it is connected to your reactor, because there is a line reactor here. There is no transformer in this substation. Okay, I will show you the another photographs with the transformer. This one is called the line reactor, which helps to minimize the line losses during a light load condition. Then this is the control buildings, where normally all the control and protection system and monitoring systems are installed. So what we are understanding from the line diagram and the layout and the physical site, this all you just consolidate together so that you can visualize what is substation. Then now you say the electrical design engineer is doing the substation. It is not like that. It is a cumulative, or it is a cascade, or it is the team effort of the civil engineer and the electrical engineer and the mechanical engineer. Of course, the manufacturers, the process industry is. So let's say if someone is giving the bare land, what we need to start, we need to understand the level of the land. Maybe ups and downs will be there. So the civil engineers will understand the level of the land. Then they will start design the leveling of the land and how the drainage system should be, and the road of inside. So these are all roads. The black color which you are seeing, these are all roads which helps to access the equipment. Okay, these are also part of the civil engineer. Then the design of control building. Then all the switchgear equipments, it is not going to be placed just above ground. There is a foundation, like the residential house, how we are making a foundation. Similarly, there is a foundation for each equipments. So all the foundations will be covered by the civil engineers. Then the structural design is a part of civil. So now when you look at it, this all the overall layout, it is a joint effort of civil engineering as well as the electrical engineering. Okay, let's move to the next presentation. Okay, now actually what I was trying to indicate in this slide, I think you can able to understand, this is the fence of the substation. What are the components we seen? One is the transformer. Then when you below ground in 1 or 2 feet lower, you can see we will place some conductor that is called earthing conductor. So normally in high voltage substation, when you dig the ground, you can find a lot of conductor below ground, which is approximately, we will place the conductor 1 feet or 2 feet with required spacing, which helps to minimize the step and touch potential, which is called the safety of the operator. For example, there is a person is standing on the ground. The same time there is a fault occurring on the transformer or any of the equipment. There is a conductor is then the earth fault current is flowing into the ground. What the mesh? This is called the mesh. The grid is helps to distribute the flow of earthing current across the ground. So by that way, the person who is standing, it is not going to be electrical. So, and also above ground, there will be a earth mat will be placed. That is what indicated here. Okay, so in a nutshell, what I'm saying, there is a plane of ground. On the above ground, there are equipments. Below ground, there is the foundations and earth mat. Above ground, there is a earth mat for the operator. These are all the components or equipment infrastructures of the substations. Okay, let's look at another photograph. So here what we are saying, this is the transmission line, the outside of the station, the fence area. Then you can look at, this is the transformer. Then this is the control room, control building. Okay, these are all roads. Okay, we are going to talk about the individual equipment. I will show you the photograph, what is in how it will be look like. But in a nutshell, you just understand what is the substation, how it will be look like. Then how the transmission line is connected. So transmission line is connected with the steel structure through insulator with the conductor. Then conductor is traveling all along all the equipment which I told you: disconnector, a lightning arrestor, disconnector, voltage transformer, then circuit breaker, current transformer. Then it's connected to your bus bar. Then from the bus bar, one more time, the disconnector, circuit breaker, CT, VT, then lightning arrestor, it will connect it to your transformer. So this is what we need to understand about the layout. Okay, let's a little more closer view of the transmission line and how it is connected to your line feeder. Okay, so from this transmission line, this is the let me explain the component first, then let's understand the scheme. So this is the tower. From the tower, you can see there is a conductor is coming, and the first component is the lightning arrestor. This is actually a line reactor. Okay, it just helps to compensate the line. Okay, this is another component. Then this is the current transformer. Then this component is a circuit breaker. Then this is called gantry. So how it is connected from this gantry? It is connected to your transmission line through the insulator. These are all insulator. There is a small component if you have a close view, and you can see there is a porcelain insulator. You can see it on the roadside, or it's a glass insulator on the towers. So which helps to connect the conductor. From the conductor, there will be a jumper connections. There is a further conductors which helps to connect all the equipments. It's all along, it is going to your bus bar. So the bus bar is normally a aluminum tube, which is called rigid bus bar. If there is a conductor, which is called the strung bus bar. Okay, further closer view of the equipments. This is the circuit breaker. Then the conductor is connected to your current transformer, then the disconnector, then bus bar. So you can say it is a kind of typically it is a line feeder or transformer feeder. These are the components involved. So this component, it have the structure, and you can look at the person. If he is standing, it will be with the safety and 2.4 meter above ground with the help of structures. So in the design of substation equipment installation, there is a design of structure and foundations below ground. Then above ground, there is a equipment. So equipment in the sense, this is the equipment of current transformer. So this is the current transformer. So this is called the structure. Let me mention is a structure, and this is the equipment. Okay, what you are seeing in the right hand side of the photo, somebody is installing the dead-hang circuit breaker. Okay, there is a circuit breaker classification. So this is called SF6 circuit breaker on your left hand side. The right hand side is a dead-hang circuit breaker. It is SF6 again. Okay, so when we go for an installation, there are a group of people with a crane. They are trying to install the equipment, and there is a safety involved. Then there is a step-by-step procedure how to install the circuit breaker. These all come into picture when you go for a substation installation. And also what you can able to understand from this, in circuit breaker, you can see there is a operating box. This operating box helps to receive all control cables from the control room. So from here, there is a control cables will be traveling through the cable trunches, which is going to the control room. So the control room you can see somewhere here on the back side of the structure. Okay. So this control cable helps to carry all the command and all the signals from the circuit breaker or current transformer and the disconnectors, and which will connect to your control system. Now the another enlarged view of the transformer bay. I hope it's updated. Okay, the transformer, this is the transformer. So the transformer, this is the lightning arrestor. As I said, it's the surge arrestor should be on the primary as well as secondary. So this is the surge arrestor here, and you can see the surge arrestor on the other side of the transformer. So this is called the primary bushing, which is, this is approximately 220 kV. When you look at the bushing, you can able to understand what level of voltage it is. Then the transformer primary, which is connected to your current transformer and circuit breaker, and it is connected to your bus bar. So the bus bar, if you look at it, this is a rigid bus bar. This is a tube which is running through, it is intersecting the line feeder and transformer feeder. Okay, and also what you need to note in the substation, there are some gravel below ground. If you look at the ground, there are stones placed on the ground. The reason is, when you operator is standing on the field, as I said, below ground there is a earth mat, which is called the conductor, or placed approximately 1 or 1.5 feet below ground. Then above ground, they will put the layer of 150 mm of gravel. It means stone. It will be like a bed. You are creating a bed for the distributing the fault current when there is a fault within the station. So the person is standing on the field, which helps to distribute the earth fault current so that the person is not going to be electrified. So let's move to the another photographs. So okay, now what you are looking in the, okay, first photograph, let's say, let's put first, second, and third, then fourth. Okay, there are 4 photographs. Let me explain one by one. If you look at the transformer, you can look at, there is a foundation here. Okay, this foundation basically designed by the civil people based on the size of your transformer, because the transformer is basically, it inside the transformer there is a oil and winding. Okay, if any abnormal condition, if there is a oil spillover, so this foundation will helps to collect the oil without the spillover across the substation. It should not happen. So even that is the international practice. Even if you go to some of our local substations, it may not be there, but this is the real engineering practice we used in international projects. So this is called the sump, the transformer sump. So it is like a periphery of the substation. It will be, there is a concrete work, and its depth of 600 mm, it approximately 2 feet, which helps to collect the transformer oil during the abnormal condition. Then photograph 2, what you are looking, it is a complete transformer feeder bay, which having the disconnector, then surge arrestor, then there are some auxiliary equipments as well. Then this side, the primary side, if you look at, there is a circuit breaker. This is circuit breaker. Let's put the circuit breaker means CB, we can say. So circuit breaker, then it is connected to your bus bar. Then photograph 3, it similarly, you can look at this, a large 220 kV transformers. Then photograph 4 is a closer view of the transformer having the, okay, now here, if you look at bit of design, this surge arrestor is mounted on the transformer itself. See, okay, when you go for a design, this kind of optimization, I would say, if you go for a separate structure and foundation, it will be costly a solution. So some people, what they are doing, they are placing a surge arrestor on the transformer itself. So it will be communicated to the transformer manufacturers. So during the phase of the construction, so they will give up just a supporting structure to mount the equipment, I mean the surge arrestor. Okay, let's move to the next presentation. I'm in slide 20. So if you look at this substation, there's a kind of a different pattern of structure photographs I want to show you so that people will understand what is the real time situation. Okay. Okay, then I'm in slide number 21. Have a look on it. Then quickly we will wrap up for the substation for the other slides. Okay, this is called the bus bar. Is a rigid bus bar. This is also the bus bar. So the conductor is going to the traveling to outgoing. It's going outside. This is also a rigid bus bar. Okay, so key role of the substation electrical engineer. These are the points. So we need to understand the client requirement, and we need to do the modeling of the stations, and we need to select the equipments, and the equipments, how many quantities are required. Then what are the auxiliary items like a earthing, grounding, there is a light fittings, then control cable quantities, cable trays. This all the works will come into picture for the electrical engineer. Then they need to coordinate with the civil and structural engineer. They need to coordinate with the product supplier who is supplying the transformer or other switchgear equipments. Okay, when you do for a design of substation, there is a code of practice. It is not, it is over the period of the experience, there is an international code. It is like a booklet. It's covering the each and every topic, how the transformer protection should be, how the transformer should be constructed, what are the different possibilities of construction. So that all is defined in the code of practice. So the majorly there is a IEC is a international standards, or IEC or IEEE or NFPA majorly covering the fire protection, then some ISO standards. In Indian code of practice, the Bureau of Indian standards are there, which helps to guide the application designer who is doing the substation. Of course, definitely the safety is concerned when you go for a substation. There are safety equipments, safety jackets, then fire extinguishers. After installation of station or during the construction phase, and the gloves for operator. These are all essential items for the substation safety is concerned. Okay, now we look at the circuit breaker alone. So this is called the SF6 circuit breaker. Normally a SF6 for above 72 kV. Then vacuum circuit breaker is for the below 33 kV and 11 kV equipments. Okay. Then when you look at the disconnector, there are different types of disconnectors are there. So basically what I have shown in the photograph is a double break disconnector. When there is a break, the center insulator will rotate and your blade will be move on this direction. Okay. So this is called the pantograph. It will go down vertical and upward. It is another type of disconnector. Okay, this is called the current transformer. So when you look at outside, is like a bare porcelain bushing. So when you make a cut section of the current transformer, there is a winding inside. Then the winding will, there is a mutual induction. Of course, the primary winding is there, secondary winding. Then it will convert high current into the instrumentation current, which is 1 amps or 5 amps. Normally, it is a oil-filled type for the outdoor purpose, and gas insulated also available in nowadays. So next is voltage transformer. So outside is a bare bushing. This is called bushing. This is called terminal. So this is called the secondary box, where you can take the 110 volt for your control system or instrumentation purpose, monitoring purpose. And this is called the lightning arrestor. So basically it's a zinc oxide. So it's like a semiconducting device which helps to, when during the surge into the surge arrestor, what will happen? The semiconductor will allow the higher current into the ground. Okay, so then there is another equipment I would like to say is the 33 kV and 11 kV indoor switchgear. The switchgear basically it helps to, it comprises all the component. For example, there is a bus bar, then breaker, then current transformer, voltage transformer, then this is the cable. So normally the 33 kV and 11 kV, it will become like a consolidated panel. Okay, what we looking before in the outdoor is a high voltage. There is a individual components are there. Now it will converted into is a small component, because 33 kV it will be roughly 1 feet or 2 feet. So all the component will be accommodated in the metal box, which is called metal clad switchgear. So this is the relay for monitoring the whole equipment. Okay, so this is called the switchgear panel. So when you look at the control room, so the control room basically it's having a switchgear room, auxiliary supply room, the battery room, then control room which having the control panels. Then there is a office and admin people. Then there is a restroom. These all the rooms are mandatorily required for the controls building is concerned. So the battery rooms basically, because the batteries are helps to when there is a power failure, what will your control system will operate with the battery backup to protect the substation equipments. Okay, now you look at the control and automation solution. So from the switchgear, what we look at the switchyard level, this is called the switchyard. What you see in the so far photographs, this all process level. Then the electronic devices will come, and it will hardcore cable will be connected to your all the equipments for the monitoring for the operator, as well as it have the automation purpose. This is called bay level. Then substation level, there is a personal computer. It means PC or telecom equipments, which helps to monitor the substation physically for the operator. And even there are control system in a remote end, maybe a one substation, there will be a group of substation is monitored from the control center, is more than 100, let's say 50 substations. So these regional control centers have a multiple PCs, multiple screen. It helps to monitor your various substations, helps to do the energy monitoring as well as the reliability of the whole network. So these are different level of substation automation. So one is a switchgear level, then bay level, then substation level, and control system, control center level. Okay. So I took some photograph of the substation. So substation, substation automation, I would say. So this is the monitoring purpose. These are the computers. These are called control panels. These are telecommunication panels. So it will physically, it will be look like this. So all these relays are the intelligent electronic devices which helps to monitor the equipments with the help of your current and voltage transformer. As I said, this will monitor the current and voltage, then it helps to give the command to your circuit breaker. So it's a kind of a architecture. Just to have a look, because I'm not elaborating, we are moving to the next level. Then there is a telecommunication which helps to from one substation to another stations. This telecommunication is either a digital communication or is a power line carrier communication, which helps to monitor the substation from one end to the another end. For example, there is a fault in this high voltage line. What will happen? This substation, let's take, this is the substation 1, then this is the substation 2. So both substation breaker, this is called breaker. So breaker will open by communicating the command signal from one end to the another end, because this substation S2 substation will communicate through this fiber optic to the other station. So there is a fault, so I have opened, so that information go to the opposite control system, then this will take a charge, then it may give a command to the relays. So because okay, we are in the introduction of the station, so maybe I am not covered the following detailed informations, so which will be covered in the forthcoming sessions. Maybe the selection of switchgear, how to select the switchgear, what is the air insulator switchgear, what is gas insulator switchgear, what are the automations are there, what are the type of substation automation, how telecommunication systems are working. These are all will be covered in the detailed session. Okay. Then how to do the fire protection for the large transformer. Okay, so far, so we covered the substation. So let's quickly move to the your distribution system. Before that, let's. So Arivulakan, I hope still we have time, maybe at that 20 minutes. I think
the session ends by 11:30, sir. Maybe we can take, I think, another 5 to 10 minutes.
5 to 10 minutes quickly. Okay, right. So the distribution station, as I said, okay, we have talked about the substation. So what we are going to do quickly wrap up this pole mounted transformers and the transmission line, how it will be look like, what are the components involved. That is what we are going to look into. Is then by that way we'll understand the brief information of the distribution system. So the distribution system, normally if you look at this line, then there will be multiple poles and it will be distributed across the town. Okay, basically you can understand by this way. Either this distribution network normally a 33 kV and 11 kV, then down the line low voltage distribution also there. It's a 415 volt and a single phase 240 volt. So when you look at the components, the core components are insulators, then conductors. As I said, the arrestors are there. Then either a wooden pole or concrete pole. Normally in India, most of the places are concrete poles. This is the concrete pole. It will then these are all steel channel. So these are the components involved in the distribution system. So basically this photograph, it indicates it's a T-type distribution system. So normally the engineering representation, normally it will be look like this. So the previous one I have indicated, shown the photograph. So what you are seeing is the representation of an engineering term. So how, when you do the design, so all these components will be properly placed and positioned with the proper dimension. For example, this is the transformer bay. This is the transformer distribution model. So all these components are indicated here. Let me explain for the transformer is concerned. So these are the couple of your transmission distribution poles. Okay, this is the typical the transformer pole mounted. Normally you can see it in road on the left hand side of the road. So which cover basically a transformer. This is the fuse. Then these are the surge arrestor. So there is a line coming, then from the line it is down to transformers, isn't it? So some couple of photos. So actually from the transformer, these are the low voltage which is traveling to your low voltage distribution network. So this is the high voltage. Sorry, the medium voltage. Okay, so basically for the transformer bay is concerned, always there is a fuse is mandatory, because if any fault on the transformer, this fuse will blown out. Because when you say the substation is a circuit breaker is not a blown out, but basically a circuit breaker will be open and close in a high current and high voltage application. When you say in the distribution side, this fuse will be blown out. So this is basically a ceramic and it have a fuse link inside. Okay, so the conductor, I'm not talking about much, because the conductors, different types of distributions are there. One is a bare conductor, or is a insulator conductor, aerial bundle, or covered conductor. There are different types are available. So these are the insulators. So this is the glass insulator, then this is the porcelain insulator. So when you go for 33 kV, there will be 3 insulators. When you go for 11 kV, there will be 2 insulator, considering the different design and models. So these are the different hardwares we used in the distribution network, basically there are two types majorly. One is the ceramic insulators and composite insulator. Composite insulators are basically is a rubber, kind of a silicon rubber. It's a composed form, and it is doing a very well insulation function, providing the insulation function. And these are the hardware fittings. As I shown in the previous photographs, there are a steel channel. So I have just listed all the components separately. So these steel structures and the hardware, how the fittings are connected together. So these are the component involved. You know, just to understand, there are many components involved in the distribution system. So some of the components I have indicated here for you to people to understand what is the volume of work involved in the distribution system. Okay, so I just want to show some of the leading manufacturers in the high voltage switchgear and the power transformer. So basically, it's a known company for some of you people. So you can take a note of it, which may help you to study more on the individual manufacturer details and product. I will keep this slide for one minute. Okay, so these are the leading contractors. Take a note of it so that it will help you, because I'm not going to brief for a short span of time. Then these are the global leading contractors. So for example, I would say the L&T is a 22 billion US dollar is a total revenue. So even the Bicos is having around 35-40 million US dollar. Okay, so let's move to quickly. I think Vairavelavan, shall I take some of the questions? I think you have sent through your.
Yes, Mr. Vairavelavan, it was sent to your chat box also.
Okay, just a minute. Let's me. Okay. Okay, there is some fundamental question. If the voltage value is increased, means the transformer size will also increase. Do you have any IEEE standard reference? So basically, you need to understand the process. It is not just like that one customer will come and you please do the design. It is not like that. So there is a process for substation design. The customer, for example, let's take the Maharashtra government. So the Maharashtra utility, let's take. So those people, what will do? They will select the substation location and they will understand what is the volume of substation, what is the size of the station. Then they will decide how much voltage levels we need to what is the voltage level. Then they will decide the transformer size based on this. Okay, so it is not a IEEE. IEEE is a code of practice to do the design of a substation layout. When it comes to substation sizing, when say is a 750 kV substation or is a 400 kV station, which is going to be decided by the requirement of the town. For example, there is a new town we are developing, or there is a by population it is going to be in near future, it is going to be developed in those areas. So they will look at what is the nearest generating station, what is the operating voltage, which is the convenient for the loss of transmission line. So all these factors will be taken into account. Then they will size the transmission line followed by your transformer voltage level. When there is an increase in voltage, there will be a sizing of the transformer will be bigger. When normally let's say 200 kV transformers will be 125 MVA or 200 MVA, that range. 750 kV, if you are going, it will be a 500 MVA. So I cannot conclude with IEEE standard. IEEE standard is giving just a guidelines for the application designer. Mainly the volume of requirement will be decided by the customer and consultant for the substation design. Okay. Okay, what is the difference between isolator and circuit breaker? I think I have explained it in my presentation. The isolator is a no load operation. The circuit breaker is the load closing device, which means circuit breaker normally when there is a fault on the line, the breaker will open and close. Oh, sorry, breaker will open. Okay, if breaker is open, I want to go for a maintenance of the line. What I will do, I will open the disconnector, because the circuit breaker is based on the command from the control room or control panel. The isolator is a no load device which helps to protect the person when he is in the maintenance. So that is a basic difference between isolator and circuit breaker. So I will take one more question, so then we'll wrap up. The voltage value is increased when the transformer is also. Okay, so someone is asking, where did we get the data of data sheets of the transformer? So there are the leading transformer manufacturer I have mentioned in my slide. Let's take ABB or GE or Siemens. You just go to their website, you try to download their catalog of the power transformer, you will understand the basic parameter of the power transformers. So that's where you can begin your basic or introduction to the transformer selection. Okay. Just 2 minutes, Arivelagan, I will close it. The last 2 questions maybe for the people.
Please, Mr. Vairavelavan.
Okay, some people asked, can we link the couple of 2 generating station at the time of it the same load? See, actually, I hope you see in my beginning of the presentation, I have indicated 2 power plant is connected with the same station. And I shown the India map. If you look at the grid, there are multiple transmission lines from the different voltages are interconnected. And when you interconnect, there will be a compensation device and stability of the network. There will be a system voltage monitoring device. There is a synchronizing the one line feeder to another line feeder. There is a synchronizing concept. Okay, sorry, we are not able to get into the detailed design of the design of the station. Working function of the station, but I hope I covered only the introduction level. Yes, definitely we can couple the multiple generating station into the one substation through one substation. Yeah, as I said, please tell about the busbar. Busbar is just a conductor or aluminum tube which helps to interconnect the multiple feeders in a one point. That's all. So, Arivelagan, or do you want to cover any point which I missed? Do you think it just pop up so that I can tell about something?
I think everything is covered.
Okay, fine, right.
There is any further queries? I think we can in this session.
From faculty, if you have any doubts, you can just tell me so that I can brief. Otherwise, we can wind up. I think.
Someone has asked like clarify the difference between circuit breaker and disconnector.
No, I think I have just 2 minutes before I
Answered.
explained. Yeah, answered already.
So
Okay, how to, sir, how do you set 130 kV insulator and 220 kV insulator? Is there any calculation? Okay, see, when you look at the 130 kV insulator and 220 kV insulator, you can see the size, I mean, the length of the bushing or length, the size of the insulator will change. So by that way, you can understand whether it's a 220 kV or 130 kV. Okay, just to go and, for example, IEC is a one company is manufacturing the insulator. You download their catalog and you try to understand the different types of insulator.
இந்த செஷனை இப்போ நான் என்ன சொல்றேன் என்ன உடனே நீங்க எம்ஓசில
Okay. Okay, I think Harivalan, we can wind up, or Ganesh, you can tell me.
Okay, sir. Thank you.
Thank you for giving a wonderful. Sorry to interrupt. Thank you for all participants so patiently and seeing my presentation. Thank you for all your questions as well. I appreciate and move forward. You need to keep work on the substation so that you will understand more about the station. I covered only just a small portion of substation basic. So still we can have to go for a long way. So maybe I will try to have a further more detailed session in advanced sessions through the Nada Saraswati College. I hope. Thank you for all the participant and faculty.
Thank you, sir.
Thank you, sir. First of all, I want to thank Almighty for blessing us to conduct a webinar in a smooth manner. And I also thank our management, principals, vice principals, and head of the other departments to grant us permission to conduct the nice, wonderful session. And I also thank the participants for their smooth coordination throughout the session. And I want to thank the speaker, Vairavelavan sir. Nice session, and so many informations are shared among our students and the participants. And we thank you for regarding the Nada Saraswati College of Engineering and Technology, sir. Thank you, sir.
Thank you.
Thank you, Vairavelavan.
Thank you, everyone. Thank you. Shall I close the session? Is okay? Shall I leave the session?
Yes, sir.
Yes, sir. Thank you.
Okay. Thank you. Thank you. Thank you, participant. Thank you. Bye.